Why aren't underwater volcanoes extinguished by seawater? We all know that water can extinguish fire, and there is no shortage of water in the ocean. So why can't water there extinguish underwater volcanoes? When thinking of a volcano, many people may imagine a tall conical mountain emitting thick smoke, resembling an erupting volcano. Furthermore, after an eruption, a large amount of white volcanic ash falls over a wide area. Therefore, subconsciously, many people think that volcanoes can actually erupt with fire. But if we observe volcanoes up close, it's not the case at all. The magma erupted by volcanoes is actually a high-temperature liquid called magma, which is fundamentally different from fire. Close-up photos of magma clearly show that it is a liquid. When we learn physics in school, we become familiar with the three phases of matter: gas, liquid, and solid, which are related to the melting and boiling points. Taking water as an example, its melting point is 0 degrees Celsius and its boiling point is 100 degrees Celsius. When the temperature is below 0 degrees Celsius, we see solid water, ice. When the temperature is between 0 degrees Celsius and 100 degrees Celsius, we see water in liquid form. When the temperature is above 100 degrees Celsius. In essence, all substances behave similarly, with melting and boiling points, and they undergo phase changes according to temperature. Magma is molten rock composed of complex rock components, and the melting and boiling points of different components inside are heterogeneous, so most magma is actually a mixture of solids, liquids, and gases. On the contrary, flames appear when a volcano erupts, which is a process of combustible materials releasing light and heat. In this flame, the main components are carbon dioxide, water vapor, oxygen, nitrogen, and other types of gases. Water is in the gaseous state, water vapor. After understanding that the substance erupted by volcanoes is magma, and magma is a molten material at high temperatures, not fire, you can understand that when underwater volcanoes erupt, magma entering the seawater is similar to continuously spraying hot water into a cold water tank. Cold water cools down the hot water, but it doesn't make the hot water disappear in the same way that water extinguishes fire. Therefore, seawater cannot extinguish underwater volcanoes. Because volcanoes are the product of thermal convection and the movement of planetary matter, these volcanoes remain active. The entire Earth actually operates according to the fundamental laws of physics and chemistry, which we have learned in secondary school. For example, the formation and activity of volcanoes can be explained by the second law of thermodynamics. It may sound very technical, but it is closely related to our daily lives. Heat always spontaneously flows from a higher temperature source to a lower temperature sink. Heat always spontaneously flows from a higher temperature source to a lower temperature sink. If we reverse the history of Earth's evolution over 4.6 billion years, we will see the effect of this law. Approximately 4.6 billion years ago, Earth gradually formed through the collision of countless planetary bodies. The energy from these collisions was converted into heat, making Earth at that time resemble a giant magma sphere, with its entire or most of the surface being magma, with surface temperatures reaching thousands of degrees Celsius. Then, because magma can flow, heavier materials sank while lighter materials rose. As the heavy matter sank, gravitational potential energy was converted into thermal energy. At the same time, the originally scattered radioactive elements within the planets gathered together, continuously decayed, and simultaneously released energy. These energies keep the magma inside Earth continuously heated. However, due to the extremely low background temperature of the universe, averaging -270 degrees Celsius, Earth continuously transfers heat to the outside through thermal radiation. Because heat is being transferred, Earth cools down, with the Earth's surface cooling down first. Therefore, the magma here solidifies into rock, forming the initial crust. Until now, Earth has developed with a fundamental structure consisting of three layers: the crust, mantle, and core, with temperatures increasing as you go from the crust to the core. Additionally, due to the continuous sinking of dense matter, its density becomes higher and higher. The average density of the crust is 2.8 grams per cc, the average density of the mantle is 4.59 grams per cc, and the average density of the core is grams per cc. Therefore, we can also think of the crust as floating on the mantle, similar to a plank floating on water. Due to the thinness of the crust compared to the mantle and core, the average thickness of the crust is only about 17 kilometers, 33 kilometers for continental crust and 10 kilometers for oceanic crust. In contrast, the thickness of the mantle is about 2,850 kilometers. Therefore, the movement of the mantle causes these thin layers of solid rock to be fractured and carried along with the mantle. Parts of the Earth's crust are shattered into fragments, and as the Earth's crust moves, some fragments collide with each other, while others separate from each other. Magma can flow, and heavy materials will sink while lighter materials rise. As a general rule, it can be understood that the boundaries of these separated fragments are very thin and fragile, and the underlying layer of material can easily break the seal of the rock layer and be pushed out to the surface, creating a belt of volcanoes along the fragment boundaries. And as the fragments move farther apart, the magma cools down after volcanic eruptions at the fragment boundaries, forming a thin layer, namely the oceanic crust. Because it is much thinner than the inner layer of the fragment, it will be shallower than other areas. Over time, water accumulates to form oceans. In fact, the ocean is formed in this way, and the formation of the ocean is closely related to the movement of the fragments. Therefore, underwater volcanoes are actually the result of the movement of these fragments, and most of them are boundaries of fragment separation. Since World War II, with humans diving deeper to explore the ocean, we have discovered long underwater volcanic belts, mostly located in the middle of the ocean, called mid-ocean ridges. They are the longest mountain ranges in the world, with a total length of about 80,000 kilometers.